Okay. So when you're going to be looking at these answers, I want you to check. Make sure your asymptotes, my asymptotes match up. Remember, when you draw these to maximize your points, tell me where you started your graph. Because if I can't see where you started your graph, I can't even try to give you partial credit. I can't pretend I know what you were thinking. Okay? I believe these are correct. I could be wrong because my brain and everything. So take a look at problem number 1 for me as I shake it into Crazy Town. It's a little bit darker. Might be a little bit better. I don't know. Do you like it better with the light on? On? On is better? Okay. We will do that. So are there any questions with this one? Remembering very important things for tangent. Tangents have a period that starts off with as pi. Since there's no number here, I'm not dividing it by anything, so my period stays pi. When I do my shift, tangent starts with a point, and tangent generally goes up. So the way I draw this is I go point, skip, asymptote, skip, point, skip, asymptote, skip, and then I go back in and I put, okay, am I talking about an upper point or lower point? To me, that's just the easiest way to do it. If you do it a different way, that's perfectly fine. No questions on 1? So you mean I got it right? This is like huge. Yesterday was just bad. All right, take a look at this one. Please be right, please be right, please be right. Again, you telling me where you start can help me determine, did you have just the amplitude wrong? Did you move your start place to the wrong spot? Were you dealing with the wrong parent function? None of those can be determined without a little bit more info from you. David, you sure? Okay. Thaddeus. Because this is a sine function, sine functions start off, and this is what worries me, because we're switching now between sines, cosines, tangents, cotangents. Sines have their period of 2 pi over b, whereas tangents and cotangents, those guys are just pi over b. Okay, does that make sense? Okay. That's probably the biggest thing that I think trips people up, because they remember what the difference is in the parent functions themselves, what they look like, but that one little characteristic. All right, let's take a look at number 3 then. A little bit ickier of a problem where the shift and the sections didn't quite match up, but that's okay. I'm not seeing the blanket looks of confusion that I saw yesterday that indicated I did them all wrong. Seriously, if you've got questions, that's what I'm here for, to answer them. And sometimes make more. No? Hey guys, guess what? You only have me 1 day this week. I feel so sorry for you. Whatever. Okay, and number 4. Big. Nothing better than a good stretch. Except maybe a good knuckle crack, right? So cute. She's like, ew, gross. Yeah. Someone needs to tell my mom that. She yells at me every time I crack a knuckle. She's like, stop it! I'm like, but it feels so good. Seriously, any questions? Let's get some life in this room. Just a little bit. Like have caffeine pumped into the air and I'll wear a face mask so it doesn't get into me. Because, yeah, that's bad. So we're good. We're okay. We kind of sort of remember this. Again, I am really happy for today because I'm hoping those of you that maybe struggled a little bit with sine cosine will get a refresher. Because today, what we're graphing is cosecant and secant. Now, I'm not sure if you can see this on your paper because it's a lighter color. I don't know if it came through in the print. Do you all have that little dude? If you can see it, great. If you can't see it, I would recommend you put those in. All that is, cosecant is what? Pairs up with what? Sine. So this is 1 over the sine of theta. So what I've got here is I just have the parent graph for sine plugged in there. And since secant is what? 1 over cosine. I have the cosine graph plugged in there. So if you can't see it on yours, go ahead and put it in. Gee, Kyle, just throw your stuff around. See if anybody cares. Now, cosecant is the reciprocal of sine. So what we're going to do is we're going to take some really nice points on the sine graph, and we're going to do the reciprocal of them. Okay? And what I talk about the reciprocal, I'm only talking about its y value here. So this point here has what for a y value? 0. What is the reciprocal of 0? Undefined. Beautiful. Does everybody have that? The reciprocal of 0 is undefined. So what do I put for an undefined? Asymptote. I'm going to draw in an asymptote here. And I'm going to do a couple more points today than what you would generally do, just so that you get an idea of where these parent functions are coming from. Another nice number to take a reciprocal of is 0.5. What's 0.5 as a fraction? 1/2. Here's where I hit it. So what is the reciprocal of 1/2? So at this point, I will actually be up here. Another nice number is 1. What is the reciprocal of 1? 1. Because 1 is just 1 over 1, and the reciprocal is 1. Okay, if I keep going, another nice point. Here's another nice point. That is again 1/2. So what will that be at? 2. We're putting in a lot more points that I'm going to ask you to as we actually do these. That's going to be another asymptote, right? Because that's 0. The reciprocal of 0 is an asymptote. Okay. What is the reciprocal of negative 1/2? Negative 2. Reciprocal of 1? Negative 1? Negative 1. Reciprocal of negative 1/2? Negative 2. And the reciprocal of 0? Asymptote, undefined. Typically, when you draw these things, and this is what this guy's going to look like. It's going to curve up and go on towards infinity. It gets infinitely closer and closer to that line. This is going to go down, getting closer and closer to that line. So what I have drawn in pink, that is my cosecant graph. The points that I use that I think are extremely important when I graph a cosecant, I actually start by graphing the related sine, top, middle, bottom, middle, top type thing, where we pass through the middle, wherever that might be. That is going to be your asymptote. And then I literally say this. I even printed it in your notes. Tops up, bottoms down. That is a cosecant and a secant graph. You graph the sine and cosine that goes with it, and it's just tops up, bottoms down. Okay? So that means whatever kind of characteristics we had for the sine and cosine, we have those same functions, those characteristics for cosecant and secant. What did the sine graph have an amplitude of? 1. This isn't really an amplitude anymore, but it is a guideline here. and that value is still going to be 1, whatever the number out in front is. What is the period length for the sine graph? 2 pi. So we're going to have the same thing for the cosecant and for the cosine. Which means that when we're talking about the sections which are what I determine where these middle, top, middle, bottom, middle points are, that's still going to be the period divided by 4. Or whatever your 2 pi over b was. So I'm just actually going to change that. It's going to be the period divided by 4. Now, I don't expect you to find all of these 1/2 and do the reciprocals of that. What I expect when you go through, you figure out your period here is 2 pi. I have no shifts, so that means I'm going to just draw my sections. 0, pi over 2, pi, 3 pi over 2, 2 pi. I figure out what the reciprocal function is going to be, cosine. Cosine would tell me top, middle, bottom, middle, top. You can sketch that line if you want, but it's not necessary. I wanted you to see how it matched with this. Then what I do is I find the middle points and I draw my asymptotes. There's one. Here's one. So I have my period. I put my sections on there so I can graph the characteristics. I've graphed my asymptotes. So now, I love saying this because everyone thinks it's so wrong. Tops up, bottoms down. I'm just going to go to a top. Now you have to touch that point. That's not optional. You have to touch that point and curve up towards the asymptote. I'm going to touch that point, curve down towards the asymptote. You must always fill from the top to the bottom of your graph. You also must always fill from that 0 line all the way up to 2 pi. And you must always make sure you put an arrow. An arrow is when you combine arrow and end. An arrow at the end of each of those segments. Yes. Top, bottom. That's it. And the middle is where the asymptotes. Yeah, kind of like a vertex. How are we doing? Yeah? Are we seeing how this can be nice and just think of it as a sine or cosine with tops up, bottoms down? So let's do some of these. To handle these problems, the way I like to do it is I will actually start and say, don't wanna, not gonna, what's the reciprocal? I don't want to graph secant. I'd much rather graph what pairs with it. So what pairs with secant? Cosine. So I'm going to pretend that this is a cosine graph with all of those characteristics. What would the amplitude of that cosine graph be? 2. Because the number out front is my amplitude. What is the period length for this guy? 2 pi, because there is no number between the x and the trig ratio. So it's just 2 pi. I don't have any vertical shifts. I don't have any multiplier to pull out. So what kind of a horizontal shift do I have? Right pi. Because inside we always do the opposite. I'm just going to graph this. I'm pretending it's a cosine graph. So I don't have any vertical shifts, so I'm going to have that middle line. My amplitude is 2, so I will go up to 2. Whoops, that's not 2, this is 2. And I will go down to 2. Since my period is 2 pi, what are each of my sections? Pi over 2, because 2 pi divided by 4 is pi over 2. I'm going to shift my graph to the right to pi So that's where I'm going to start. And from that starting point, I'm going to go every pi over 2. And I'm going to go backwards doing the same thing. I'm not going to draw the full curve, but I'm going to draw all of those critical points. So this is a cosine graph. Is that going to start top, middle, or bottom? Top. It's a positive cosine. Starts at the top. Then to the middle, then to the bottom, and going back the other way. If you really want to draw the curve through there, you can, but it's just kind of like an extra step to me. Where do I put, can you tell me one value where I put an asymptote? Pi over 2. Pi over 2 is going to be an asymptote, and it helps if I draw on the paper and not on the stick. Okay, where's my other asymptote? 3 pi over 2, beautimus. And come on, you know you want to say it nice and loud. How do I graph this? Tops up, bottoms down. It's true, though. It's exactly what we're doing. So we take a top point, and we kind of curve up, and I am way off the graph here. I grab bottom points, and I graph down. Cha-ching! Money. No, not cool. Hopefully our comfort level's okay with this. I can't tell if people are moving on to the next one or if they're just polishing up this one. Michaela, are you doing the next one or are you polishing up this? Okay. I don't want to push you. We have so much time today, folks. I'm not trying to rush you through this. So you holla at me if I'm going too fast. And yes, I just did say holla. I get excited sometimes. I just want to do more problems. Y'all know what that's like, right? Get so excited about a subject that you just want to do more. No? Devin's over there going like, are you high? Huh? What? What? Huh? What? Are you making fun of me? Okay. Boomer? Who's Boomer? Oh my God. I am sorry. I'm going to go out and get a bus and I'm going to throw you under the bus. He called me a boomer. I barely even fall under the Gen Xers. Thank you very much. Somebody just failed my class. Just kidding, please. Oh my God, Miss August person. No. It's like him calling me a boomer. Thought you were like making me out to be some character from some TV show or something, and now I'm just crushed. All right, shut up. Here we go. Next problem. I want to know, what should I think about in terms of this one? Sine. Cosecant? Nope. Sine? Heck yes. So had that said sine right there, what would my amplitude have been? Uno. What would my period have been? How'd you get pi? Right, because it's a sine graph. Sine has a period of 2 pi, and 2 pi over 2 is just pi. Do we have any shifts? Down 1. So let's do those. Oh, shift, right? That's what you said. Uh-huh. Okay, so I went down 1. I do my amplitudes. Everybody's coughing. Keep them germs to yourselves. You little contagions. Unclean, unclean. Okay. If my period is pi, what then would my sections be? Boom shakalaka. And since I don't really have any shifts going on here, I am still just going to start my graph right at the left. Right at the left? All the way to the left? It's probably a better way to say it. My sections are pi over 4, so I'm going to mark those. Doot, doot, doot. Baby shark, doot, 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 doot. Baby shark, doot, doot. No. Thaddeus. I will get weirder if you start falling asleep. It is possible. So this is a sine graph. Does sine start top, middle, or bottom? Middle, top, because it's positive. Middle, bottom, middle, top, middle, bottom, middle. And somebody tell me where an asymptote is going to go. Okay, there's one, pi over 2. Where's another one? Pi. And another one. And another one. And just in case you didn't realize, there was one more asymptote on here. 0. Just making sure you guys know that that over here is an asymptote. And say it with me. How do I graph a cosecant graph? Tops up, bottoms down. Everyone's like, no. Nope. Not going to do it. That's all I'm going to do. Make sure, and I can't stress this enough, people tend to just go whoop and kind of ignore the points. You must touch this point. Tops up. I have to turn the page to do this because I'm not very talented. Bottoms down. It's actually a lot easier to draw for me sideways. I don't know if that works for you too. Filling out the graph from left to right, all the way to the top, all the way to the bottom. Questions? All right, well, why don't y'all do 7 and 8 then? You're so smart. Do it on your own. Y'all ready for this awesomeness? Just looking at these two. Here we go. Number 7. Questions? Check number 7, please. Check to see how you did. We'll see a bunch of eyes looking up at the board, down at the paper. Up at the board, down at the paper. Up at the board, down at the paper. Any questions here? Sweet. Let's take a look at number 8. Even with it when it goes kind of like that, how it's off the page a little bit or off the grid, still give me those tops. As long as anything fits on it, just give me a little bit of it, and maybe a little bit more. Questions on that one? All right, sweet. Keep going with the next 4. Hopefully you guys really do start seeing that the more we practice this, it should be getting easier. So I hope this is feeling like the easiest one that we've done. Okay, so keep going, keep practicing. Let's go ahead and take a look at these last 4 problems. Again, hopefully, y'all caught on to the fact that we switched from secant and cosecant, sine, cosine, tangent, cotangent. Let's take a look. I'll zoom out so you can see all of them at once. And then we'll zoom back in. Just so that you guys know, you are not going to have necessarily separate sections on the test for each of the different types. The problem is you will have to pay attention to what type of a question are you given and make sure you're graphing the correct one. Did I screw up? Yes. There is an asymptote at 0 here. That's not 12. Yes, there is an asymptote at 0 here. So, still yes. Devin, you look like you had a question. Yeah? No, you're good. Epic win. I love epic wins. Anybody have questions on these 4 problems? Want a closer look at any of them? Hayden, that is a confuzzled look. Which one are you looking at? I have no idea. Which one are you looking at? 11. Okay. So if we're looking at 11, B is not 2. B, like if I wanted to rewrite this as a multiplication type problem, this would be saying 1/2 times x plus pi. So the B is 1/2. Okay? Still have a question? So do you understand that this here is saying 1/2 times x? And therefore the 1/2 has to come out. Okay? Okay. Anybody else? There's nothing wrong with asking questions, ladies and gentlemen. That's what this time is for. Well, if you insist, you have your 4 classwork problems. Your homework is the back of this worksheet. Just so that everybody knows, what I ended up doing, simply for the ease of being able to tell which unit, what have you done, I actually went back and I moved everything from graphing trig to the second quarter. So that means that your second quarter grades right now hold the following things in the grade book. There are 2 homework checks, which don't do anything to your grade. That's just the graphing sine and the graphing sine cosine tangent. 1 classwork grade as of right now, which was graphing the sine cosine tangent. And then the quiz grade. So all of that is currently on marking period 2. That way this entire unit will be on marking period 2. Okay? Makes doing replacements, retakes a heck of a lot easier. All right, while you guys are working on your classwork, I'm going to pass back your test corrections, some of y'all's tests, and I'm going to pass back your quizzes. So there's going to be quite a lot of movement, all right? Okay. Go ahead and get started on your classwork. When you're done, turn it in.